Imagine stepping into a machine. You set the dials to a specific date and time. The engine roars and suddenly, you are transported to another era. This is the captivating allure of time travel, a concept that has enthralled humanity for generations. But is it merely a fantasy confined to the realms of science fiction, or could it one day be within our grasp? For centuries, the human mind has grappled with the mysteries of time. From ancient myths to modern cinema, the idea of traversing the tapestry of time has held an irresistible charm. But what does science have to say about this extraordinary possibility? As we delve into the heart of this captivating subject, we'll uncover the scientific principles that suggest time travel might not be as far-fetched as it seems. Fasten your seatbelts as we embark on a thrilling exploration of the cosmos, where the boundaries of time and space blur, and the seemingly impossible might just be within reach. To comprehend the complexities of time travel, we must first turn to the groundbreaking work of Albert Einstein. His theory of relativity, put forth in the early 20th century, revolutionized our understanding of space and time. Einstein proposed that time is not absolute as previously believed, but rather relative. The concept of time dilation, a consequence of Einstein's theory, suggests that time can be stretched and compressed. This phenomenon occurs when objects move at incredibly high speeds or are subjected to intense gravitational fields. Imagine two identical clocks, one stationary and the other moving at a significant fraction of the speed of light. As the moving clock accelerates, time slows down for it relative to the stationary clock. This mind-bending concept, though seemingly counterintuitive, has been experimentally verified. Atomic clocks flown at high speeds have shown slight but measurable differences in time compared to their earthbound counterparts. Time dilation is a cornerstone of modern physics, underpinning technologies like GPS, which rely on precise timekeeping. While Einstein's theories laid the groundwork for understanding time as a dimension, the concept of wormholes offers a tantalizing possibility for actual time travel. These theoretical tunnels, predicted by Einstein's equations, are essentially shortcuts through space-time, connecting two distant points in the cosmos. Imagine folding a piece of paper in half. Now picture a wormhole as a tunnel that punctures through the paper, connecting those 2 points directly. By traversing this tunnel, one could theoretically travel vast distances across space, and potentially even through time itself. However, the existence of wormholes remains purely theoretical. They are incredibly unstable, and would require exotic matter with negative mass-energy density to keep them open, a concept that is still beyond our current scientific understanding. Chasing time, today's tools and tomorrow's breakthroughs. Despite the immense challenges, scientists are actively pursuing avenues to unlock the secrets of time travel. The Large Hadron Collider, the world's largest and most powerful particle accelerator, is at the forefront of this quest. By smashing subatomic particles together at near-light speeds, the LHC allows physicists to recreate conditions that existed fractions of a second after the Big Bang. These experiments provide invaluable insights into the fundamental nature of matter, energy, space, and time. While the LHC is not a time machine in itself, the discoveries made there contribute to our understanding of the fundamental laws governing the universe, potentially bringing us closer to manipulating time itself. In addition to experimental approaches, theoretical physicists are utilizing advanced computer simulations to model time travel possibilities. These simulations allow researchers to test various hypotheses and explore the potential consequences of altering the past or future. Time travel, a future reality, and its astonishing implications. The quest to unlock the secrets of time travel is a testament to humanity's insatiable curiosity and our relentless pursuit of knowledge. While the possibility of stepping into a time machine and journeying to distant eras remains a tantalizing dream, the scientific progress we are making is steadily chipping away at the barriers of the unknown. The implications of time travel, should it ever become a reality, are nothing short of astounding. Our understanding of history, our place in the cosmos, and the very fabric of reality itself would be irrevocably transformed. As we venture further into the uncharted territories of science, we must proceed with caution and responsibility. For the mysteries that time holds are as profound as they are alluring. The only reason for time is so that everything doesn't happen at once. Albert Einstein.